Greetings to everyone. This is S.ANITHA from Vistas, Chennai, and other authors are Arun Sahayara sir from Vistas, Chennai, India, and Alan Melvin sir from University Malaysia Palace from Malaysia. The paper titled is The Study and Analysis of Various Crop Prediction Techniques in IoT Network. And this is an overview of crop prediction techniques from several research papers. And as a result, we found out the issues that still has to be addressed in the crop prediction techniques. The abstract of the paper is in agriculture domain. There are several researches been going on in predicting the crops or predicting some of the diseases which is there in the crop, so something like that. So there are two main issues in the agriculture field: the selection of crops and altering climate condition, and by providing the solutions for crop suggestions depending upon the climatic change. So the research gaps and issues of the existing techniques are devised in such a way that the motivation for developing an effective method for crop prediction technique in the IoT network is being discussed, or it has been revealed. So as an introduction part, the IoT is being used in everyday basis. So IoT is being playing a vital role in our daily lives, extending to the perception in identifying and in predicting some of the available data which we get from the sensor. So in agriculture domains or in the environmental domain, like in agro industries, IoT has been adapted for controlling as well as for diagnosing. So controlling some of the crops which is being cultivated by analyzing the parameters, and diagnosing which has to be cultivated, which crop has to be cultivated at which place and which conditions or something like that. So precision agriculture or the smart agriculture utilizes this IoT feature to assist or to manage the crop production by optimizing the quality of the crop by increasing the nutrients of the crop, or by reducing the pesticides which is being used based upon the soil, or based upon the temperature or humidity, something like that. And only the maintenance or or not only the solution for having the healthier crop, um, not only the solution for the healthier crop, but also we need to include some other factors which has to be involved in giving the healthier production in the crop. So the IoT is being considered as an integrated unit to to execute the workflow, the energetic workflow, but throughout the agriculture domain. So the utilization of the sensor as an intellectual technique will offer a more maintenance in the quality of the field for yielding the better high quality crops. So the various techniques on the basis of crop predictions in the IoT network has been studied, and the review has been studied, and some of the technique has been analyzed, and some of the suggestions for the future enhancement has been given in the paper. So several papers has been studied. For the consideration, we have taken only 25 papers, and the 25 papers has been divided based on their techniques. So these are the different techniques it has been used. So hardware based, machine learning based, optimization based, parallel processing, statistical, deep learning, and graph. So I'll just give you the overall concept of each and every paper, so that it will be easy and it will be precise. It will be easy and precise to understand what each and every technique is just concluding. So first is hardware-based techniques. So I have 6 papers for hardware-based techniques. So let me give you the subtle explanation of all the 6 papers. To start with the first paper, they have analyzed how the watering can be done, but at the end of the research, they have given the control of switching and on of the electric system to the farmer. So manual control was there. So that was the main drawback over there. And the second paper, they focused on the monitoring of the crops. So monitoring alone with the Arduino controller, and the web page has been created to get the data from several. I mean, anywhere they can get the data with the help of sensor. So they are compromising on the security. So security part, they need to enhance, because need to avoid the extruder or the intrusion of the third party. So the third one, they have extended to the cloud-based smart farming infrastructure from the Things board. So in Things board, they will collect and manage the data from the sensor. So in the future, they have included the cloud-based monitoring system, but still exploring data like they focused on the potato disease here. So they need to train their system with the other diseases. Such data has to be trained to explore more diseases, more crops. And the fourth one is based on they confronted the agriculture problem, but they also suggested some of the techniques to improve the quality crops, even though they included the parameters like soil, nutrients, moisture content, density of weeds. Because of all these things, more volume of data will be generated, but it is difficult to store more volume of data as far as this paper is concerned. So applicability of wireless sensor network in IoT cell phone. Here also they are focused on the cloud-based. So since it is a cloud-based, since it is an we are considering the historical data, the some of the features, some of the parameters has been included, and which reduces the accuracy, because some of the important features like temperature, soil humidity were not considered. So since it is not considered, the results that we get is not that much accurate. So that was the drawback of this paper. And the real-time data crop for crop prediction using IoT. So wherein they utilized the climate and the type of soil. The soil moisture level indicator sensor has been used to get the climate and weather. And the information about the moisture and the pH value is passed with the Raspberry Pi. Even though it has been done with the soil moisture level and all, it is still predicting the method is still predicting the climatic risks that will minimize the hazard. And it has also failed to give the standard sustainable crop growth for one such period of period. It is giving the solution. For other such period, it is not providing that. There is no constant solution with this paper. So next is machine learning techniques, wherein I have selected 5 papers. So I'll give you the overview of what each and every paper is carried out here. So first paper, they have used 2 models, that is the comfort ratio model and the a cloud-based model, wherein they will have all the microclimate parameters like temperature and humidity. So since it is focused on microclimate parameters, they have reached efficient analysis, but still this microclimate parameters maintenance is very difficult. And the next one is smart IO monitoring system, wherein they used with the potatoes and tomatoes, and they worked well. But the human intervention is very much needed, even though it has been automatically done or it is manually done. But the human intervention is very much needed. So that is the drawback of this paper. And they focused on only potatoes and tomatoes. So that is drawback. And the other thing is the other paper which is focused on the soil quality and the crop growth, and the aspects like issues and irrigation issues, humidity, and all such things are considered. But when coming to the data, the large amount of data is very much difficult to handle. And the other one is where the efficiency was improved by combining several sensors, but and they have reduced in taking the wrong decisions by selecting the crop and increasing productivity. But parameters like soil nutrients and rainfall were not considered in this paper. And crop yield production and the disease detection using IoT approach. They have included all the parameters, but the humidity and the temperatures, such parameters still need to be addressed so that it will increase the efficiency of the paper. Next is optimization based techniques. In optimization based techniques, um, we focus on the firefly algorithm. This firefly algorithm is going to predict the optimum climate condition, and also it is going to predict the cultivation of the crop. And even though it is going to predict the So it is predicting the cultivation of the crop. Some of the parameters has been not considered while going for while with the this algorithms. So the Firefly is identifying and predicting the parameters for maize. So it has been for the maize, and it is maximizing the profit successfully. They are considering the climatic variables like what temperature, rainfall, and irrigation, and yielding much of the prediction process in an efficient way. And they are giving the data storage in the cloud, and the cloud will be updating the accurate data continuously. So what is the multitasking of the monitoring system is still has to be governed, and it still has to be considered when it is going for the large scale implementation. So the next one is simplex algorithm support, wherein the model suggested some of the agro data that were pertinent to the crop, and type of soil and varieties, and help the farmers to maximize the parameters with the effectiveness. And as far as this is concerned, the study has to be done. The problem in the agriculture relating to the maximization of the farm output and the minimization of the expenses that they are making, and other factors like agriculture has to be addressed. Other factors has to be addressed with this simplex algorithm approach. So the output is more important when we consider the simplex algorithm, and the prediction is focused on some specific parameters, and the other parameters also has to be addressed, like the temperature, like the humidity, everything. So parallel processing technique, distributed parallel simulation methods for pest control and crop monitoring with the IoT assistance. The concept is it is used for predicting the crop, and was devised for controlling the pest and monitoring the crop. It is minimizing the stress of GPU and sharing the everything is visible, but the tech it is focused on very less data. So like various data has to be addressed when it is considered to be when it considered as an agro industries, and statistical based data is based technically. We are going for the agri prediction model. Agri prediction model is just combining the wireless range model for predicting the potential crop predictions. But the drawback is the time and accuracy is not to the extent, but the real time monitoring was difficult in the like real time monitoring in the sense like mobile based application, how well it is communicating with the farmer, how the efficiency, the cost, everything. So next is deep learning based technique. I have selected 4. So overall in deep learning, they have used cloud, and they have used some of the Bayesian networks, and they've used several precision algorithm techniques, and they've used encoder and decoder framework. Every technique and every concept is having some of the drawbacks which has to be addressed, and which has to be implemented which has to be improvised in the future implementation, which is based on the uh, crop prediction. So in the graph based technique, we will be using on the structured data. So some of the unstructured data or the raw data which we get from the sensor has to be handled, has to be designed in such a way to improve or to reduce the energy which is consumed um, um, to have the precise prediction in the crop cultivation. So So these are the different techniques in which the crop production methodologies have been used. And what are the research gaps and issues has been found is the precise forecasting of environmental aspects is a complicated and nonlinear temporal problem affected by several external and internal attributes, making it complex to predict the trends of the future variants. As the aforementioned technique was devised for specific application, their efficient is degraded whenever the database and the operational conditions were altered with respect to time. Various environmental aspects have complicated the nonlinear relation with a noisy interference that makes it complex for predicting various attributes at the same time. One of the substitute of this problem compromises maximizing the production, but to fulfill this, it becomes an essential that advanced options should be adapted to improve the capacity of soil and preserve environmental resources. The IoT is acquiring more focus with huge alternatives for helping the farmer with visualization, models, and sensors. So the gap is that we need to serve the environmental resource with the less exposed to the techniques like sensors, and we also need to improve the capacity of the soil so it will yield high rate of cultivations. So the conclusion is the major challenge faced by the crop production model is the majority of the conventional methods suffer from poor accuracy. So we have so many methodologies which has been addressing so many parameters, so many issues, which is the agriculture is facing, but still we need to address with an efficiency of providing algorithms, more of efficient algorithms to predict the crop cultivation in an efficient way by reducing the technological effect on the environment to preserve the resources that we have that the nature has given. So the main drawback that we solved in the near future by employing the novel crop prediction strategies. So normal crop, so we should expose the sensors to the environment to get the data, but the effect of the sensor should not affect the environmental resources that the nature has been provided to us. So this was the suggestions which has been given, and all the conventional methods is providing an accuracy which is less accuracy. What I'm suggesting is to have an algorithm which preserves the environmental resource as well, and providing the high yield in crop by suggesting the farmers to fulfill their needs by maintaining and suggesting the crop which is adaptable for the particular climate condition. Thank you.